This is the continuation of question number 6. We'll be working part B. This is the question from January 2021. And in the first part, it was given that we have a curve and the equation of the curve was given. And we had to find dy by dx. We know that when we find dy by dx, which is here as a result of the answer of part A, we can find the gradient at any given point. So this is a curve here. So let's imagine any curve. So we can find the gradient at any given point on this curve. We need x and y coordinate. All we need to do is to plug in the x and y coordinate into the gradient function and find the gradient at that given point. We also know that the gradient at a given point is the same as the gradient of the tangent which passes through that point. We will be using these facts to answer part B of the question. So in part B, the question says that the curve crosses the y-axis at the origin and at point B. So we have a curve which is crossing the y-axis at two given points. So let's imagine the curve. This is our x and y axis. So let's imagine a curve that is passing through the y-axis at two different points. One of them is the origin, so it's passing through 0, 0. And the other point where it's crossing the y-axis is at P. So let's assume that this point where the curve is passing the y-axis is P. So let's name this point as P here, point P. Okay, so now what do we need to do in this part of the question? We are asked to find the equation of the normal to the curve at P. So what is the normal to the curve? Now first we need to know tangent to the curve. This is tangent to the curve, and tangent is a line that passes at a single point on the curve. So this is the tangent, and the line which is perpendicular to this and passing through the point P is the normal. Okay, so in order to get to the normal, first we need to find the gradient of the tangent, because the gradient of the tangent and the gradient of the normal are related. Whatever the gradient of the tangent is, the gradient of the normal will be the negative reciprocal of that. So first we need to work with the gradient of the tangent. So let's start by what we have in our part A. In part A, we have the gradient function, or our dy by dx, and this is the function that allows us to find the gradient at any given point on the curve. So in order to find the gradient using the gradient function, we need to plug in the x and the y coordinate into the gradient function. Now we know that the x coordinate of the point P is 0. So let's write that x coordinate of the point P is 0, but we do not know what is the y coordinate. So we need to find the y coordinate. Now how can we find the y coordinate? We can use the equation of the curve, and by substituting x is equal to 0, because we know that the point has the x coordinate as 0, we can find the corresponding y coordinate. So let's write the equation of the curve. Equation of the curve is 4y squared plus 3x is equal to 6y e to the power of negative 2x. So now we will substitute x is equal to 0. We have 4y squared, then 3 into x, 3 into 0 is equal to 6y e to the power of negative 2 into 0. So 4y squared, 3 into 0 gives us 0. So on the left side we have just 4y squared. On the right side we have 6y e. Now negative 2 into 0 gives us 0, and e to the 0 will give us 1. So basically we have all of this e to the power of negative 2 into 0 is all equal to 1. So this is into 1, which is 6y. Now we can divide the y square with the y and divide the 6 with the 4, and the y square gets cancelled with the y. We have y is equal to 1.5. So here we find out the y coordinate of the point P. So we have the y coordinate, which is 1.5. Now since we have the x and the y coordinate both, we can plug in the x and the y coordinate into the equation, into the gradient function which we have found in the part A, in order to find the gradient at point P. Gradient at point P is the same as the gradient of the tangent at point P. So let's find the gradient at point P by plugging in the x and the y coordinates at the point P. So plugging in x and y coordinate of the point P into this function, we have -3 -12 y e to the power of -2 into 0. I'll plug in for y also, because we know that y is 1.5. So 1.5. Then the denominator is 8 into 1.5 minus 6 into e to the power of -2 into 0. So -3 -12 into 1.5. Now here e to the power of -2 into 0 is e to the power of 0, which is in fact 1. So here it's like we have 1. So I'm not writing that. So the numerator simplifies quite a bit there. The denominator is 8 into 1.5 minus 6. Here again we have e to the power of -2 into 0, which again gives us e to the power of 0, which is 1. So we have our numerator and denominator. We can calculate using a calculator or manually, and we find that our gradient is -7/2. So the gradient of the tangent, let's draw the tangent here. So the gradient of the tangent, which is this green line, is -7/2. Now how do we use the gradient of the tangent to find the gradient of the normal? Tangent and normal are at right angles to each other. Therefore, the gradient of the normal will be the negative reciprocal. So we can write here, therefore, the gradient of the normal is 2/7. So we've got the gradient of the normal. We know that the general form of equation of the line is in the form of y is equal to mx plus c. Because this tangent is already passing through the point P, let's draw the tangent for clarity here. So the tangent is already drawn. Let's draw the normal. Normal is this line which is passing through the tangent, okay, and it is at right angles to the tangent. So it's this line, this is the normal. And earlier we had the gradient of the tangent, which was -7/2. Now using this, we already have found the gradient of the normal, which is 7/2, which is 2/7. And since we see that we already have the y-intercept, we can straight away write the equation of the line. So equation of the line is y is equal to 2/7 x plus 1.5, or we can write it as 3/2. So in this case it was very easy because we had a point which is already on the y-axis. The point on the y-axis has its x-coordinate 0 and its y-coordinate is already the y-intercept. So we already have the value of c because we have the y-intercept. So we can just plug in the gradient that we found, and we know the y-intercept, which is 1.5 or 3/2, and this is the answer to part B, which is the equation of the normal to the curve at point P.